So hello guys, today we are going to solve a Leetcode question that is linked list cycle. That is the question number 141. First we'll start by reading the problem statement, what the problem statement says as usual. Okay, so I'll start by reading the problem statement. Given the head of the linked list, determine if the linked list has cycle in it. Okay, so you are given the head of the linked list and you have to determine whether it is a cycle in it. There is a cycle in it. But what is a cycle? So we'll just read the question fully, and we'll understand what a cycle is. So there is a cycle in a linked list if there is some node in the linked list that can be reached again by continuously following the next pointer. Okay, so it is saying that if I am moving on the next pointer again and again, like if I am trying to move from here, if I traverse this whole linked list, if I traverse this whole linked list, then after some time, my pointer should be again to one of those positions, one of those positions that I have traversed once, that I have traversed once. Okay, so I have traversed these positions. So any of the node, if any of the node connects to the previously traveled node, if any of the nodes connect to the previously traveled node, then the linked list is known to have a cycle. Then the linked list is known to have a cycle. Okay, seems nice. Let's read the problem statement fully. Okay, then it is saying that internally POS is used to denote the index of the node that's the tail next pointer is connected to. Note that POS is not passed as a parameter. Return true if there is a cycle in a linked list, otherwise return false. Okay. So it is strictly given, it is given that you are also given a variable POS that denotes that to what position is the cycle connected to. Like if the minus 4 node here, if the minus 4 node here, 320 minus 4, right? 320 minus 4. This node is connected to this second node. This node is connected to the second node. Okay. So if there exists any sort of this, I'll just denote it by plus 1 this position as we have indexes starting from 0, 1, 2, 3. So POS is passed as a parameter that denotes to which node is the cycle connected to. That is because of the easiness of the test case so that we can create a test case on our own. Okay. Okay. So if we want to try any test case, then we can try according to that. Okay. So return true if there exists in a cycle in English, otherwise return false. Okay. So if there exists a cycle, if there exists something like this, if there exists something like this, I'll have to return true. I'll have to return true. Or if there doesn't exist any cycle, like this is a simple linked list, right? With no loops. So I'll return false. I'll return false. It is as simple as it looks. Okay, as simple as it looks. So what can be my brute force solution? What can be my brute force solution? What can be my brute force solution? Okay, 3, 2, 0, and then minus 4. Okay, so if this is connected to this to second node, and I want to traverse again. If I read the problem statement again, okay, so how is it? If I ask you how is a cycle detected? How is a cycle detected? How is a cycle detected? Okay, how is a cycle detected? If any if the current node is connected to any previously traveled node, connected to any previously traveled node, then it says that my cycle is there, my cycle is present. Okay, so how would I know that this node is a previously traveled node or not? would I know that this node is a previous travel node or not? Okay. So what I can do is, while I am traversing the linked list, while I am traversing the linked list, I could simply override these values. I could simply override these values when some random number like this, some random numbers like this. Okay. And if I'm going on next, and if I counter the same number again, if I counter the same number again, then then it states that my cycle is present. That my cycle is present. Okay, that my cycle is present. Okay, so I'll mark all of these like I'll denote this number by x. If I'm traversing like this on this path, okay, 3 I'll mark by x. I'll move forward. I'll move towards the node 2. I'll mark it as x. Okay, I'll move forward. I check whether the next node is x. No, it is not x. I'll make it x. Okay, I move forward. I'll check whether the next node, this node, is x or not. No, it is not x. I'll make it x. I'll move forward and I'll check whether this next node is x. Yes, it is x. So if x is encountered, then I want the program. I want the program to return. Then I want the program to return true. Okay, that means if the node's next value is equal to x, I return true. I return true. Okay. And if the loop ends, then that means there is no cycle. There is no cycle if the loop ends. So if the loop ends, there is no cycle, and if there is no cycle, I'll simply return false. Simply return false. If there is cycle, return true. If there is no cycle, I'll return false. How I am denoting that there is a cycle or not? I'll just simply mark every presented element by some ambiguous value, by some un uh, value that can't be present in the array, like some random value. Okay. So this I'll mark it by x, and if I move to that position again, if I move to that position again, to that position again, if I move to that position again, okay. So I suppose you are walking. Suppose you are walking on a path. Okay. Suppose you are walking on a path. You have this path. Suppose you are walking on a path. You have this path. Okay. And you are moving on a straight line. You are moving on a straight line. Okay. And as you are moving, you are putting a stone. You are putting a red stone on your path. Okay. You are putting a red stone on your path. You don't know, but you have traversed like this, and you have put the stones on your path. Put the stones on your path with a name on it. Okay, name on it. With a name on it. So if I encounter any stone that has already been put by me, that has already been put by me. So suppose if I encounter this stone again, if I encounter this stone again, then it simply it simply says that it simply says that my then it simply says that my linked list, my path, linked list or my path has a cycle, or my path has a cycle. Okay, so this is what the brute force solution is gonna be. You just mark your path, and if you go through the same path again, then you detect it as a cycle, or you and if you go to the end of the linked list, then there is no cycle. Then there is no cycle that is existing, so it would exhaust. So there would be returning false. It would be returning false. Okay, seems nice. Okay. So what about the optimal solution? What about the optimal solution? But why is the brute force solution? First, we'll understand why is the brute force solution called the brute force. Why it is not efficient? Why it is not efficient? because as we are marking our path, suppose make it like this: if we are marking our path, we are basically overriding all our values. So lost I have lost the path. I have lost the path from which I came because I have lost the existing value. I have lost the existent values that were there in the linked list. So my data is lost. My data is lost. So I can't go with that approach. I don't want to manipulate the data. I'll just simply work and I say that I have to do it this without manipulating any data, okay? So if I go to the optimal solution, if I go to the optimal solution, okay, if I move to the optimal solution, I'll consider this as my linked list for, okay, four node linked list. And what I'll do is I'll mark it by this. That means there is a cycle that is connected from minus 4 to 2. There's a cycle that is connected from minus 4 to 2. Okay, okay, seems nice. Okay, so, so I suppose I'll make a pointer. First is a slow pointer, and second is a fast pointer. Second is a fast pointer. Why I am going with this approach? Why I am going with the tortoise hare approach? Tortoise hare approach. I am going with the tortoise hare approach here. Why? Okay. Why I am going with the tortoise hare approach here? So I'm going with this here because going here because as my fast pointer if my fast pointer moves at 2x speed moves at 2x speed if my fast pointer moves at 2x speed and my slow pointer and my slow pointer moves moves normally, okay, fast pointer and my slow pointer moves normally. Suppose we have two people walking on a path. First is me and second is you. Second is you. Okay, second is you. Suppose I say that you are walking faster than me, you are walking at 2x speed than me, and I am walking normally. I'm walking normally. So if there is any cycle in our path, suppose this is the path that we are following. Suppose this is the pathway that we are following. Suppose sorry for my drawing. Okay. Suppose this is the path we are following. Okay, and if I tell you that you have 2x faster speed than me, you have 2x faster speed than me. So, if you have 2x faster speed than me, then there comes a point where you would have traversed the whole linked list, where you will traverse the path, and you will meet me. You will meet me at some point. You will meet me at some point. You will meet me at some point. Why you will meet me? Why you will meet me? Because you are walking faster than me. So you would cover 2x distance than me. If I covered x distance, you will cover 2x distance than me. Okay. So there comes a point you will complete the whole path, and I am in the middle of the path somewhere here. You will complete the whole path, and I'm in the middle of the path somewhere here. This is me. So if I move forward, you will also move forward. Okay, you will still be faster than me. So there comes a point somewhere here, or anywhere on the path, where your and my position will be the same. Your and my position will be the same. Okay, so if our position is the same, that means that there is a cycle. There is a cycle that we are rotating in a path. Suppose if we are like jogging on a normal road, and that road never meets with the previous path. Okay, so you will jog, and you will meet the end point. You will never meet me again. You will never meet me again. But if there is a circular loop that we are jogging in, okay. So if you are traversing 2x speed than me, and I am at x speed, so if you are traversing at 2x speed, you will definitely meet me at a point. You will definitely meet me at a point. because you will definitely meet me at a point, because I am covering the circle at some speed x, and you are covering the circle at some speed 2x, some speed 2x, and you are covering the circle at some speed 2x. Okay, I'm covering the circle at some speed 2x, and you are covering the circle at some you are covering the circle at some speed 2x, and I am covering the circle at some speed x. So we'll meet at a point. Okay, if there is a straight path, we'll never meet. We will never meet. If I apply the same logic, if I apply the same logic towards a linked list, suppose this is the linked list, 0 and minus 4. Suppose this is the linked list, okay, and this is my loop. If I do the dry run, if I do the dry run of what I was saying, my slow and fast point are both at the same position. We both start at the same position. Okay, we both start at the same position. So we both start at the same position. This is my first pass. This is my first pass. This is my first position. Okay. So what would be my second position? My fast pointer would be moving like fast pointer would be moving like fast of next to next, and my slow pointer would be moving like slow ka next. Okay, so this would be slow would be moving 1 point, whereas fast would be moving 2 points. Okay, so after one iteration, after one pass, where would be my where would be my slow pointer? Where would be my slow pointer? My slow pointer would be somewhere here, and my fast pointer would be here. See, because fast pointer has come from here to here, whereas my slow pointer has come from here to here. Okay, my fast pointer is twice as slow, fast, twice as fast than x. Okay, okay, makes sense. Now, okay, makes sense. So I'll just move forward again. I'll just move forward again. 3, 2, 0, and minus 4. And this is my connecting. Now for the next pass, where does my fast pointer comes? So if my fast pointer is currently here, my fast pointer would move two positions, that is this position and this position. Okay, so my fast pointer would be at this position, and at the same time my slow pointer is incremented. So my slow pointer would come here. My slow pointer is here. Okay, okay, makes sense. Okay, so my slow pointer is moving at one unit each. My fast pointer is moving at 2 units each. Okay, suppose I consider my fourth pass. 3, 2, 0, minus 4. 3, 2, 0, minus 4. Okay, and this was the location of my fast and slow pointer respectively. So my fast pointer would move 2 steps. So one step and then 2 steps. So my fast pointer would be coming here. Okay. And what about my slow pointer? My slow pointer would also move 1 step. That is, the fast pointer and slow pointer both comes at the same position. Both come at the same position. And when you are running across a circle, then only you can cross the second person again. If you are not running across the circle, if you are not coming to the previously traversed path, you cannot ever cross again. You cannot ever cross one another again. Okay, each other again. Okay, makes sense, right? See, if I like show you all the traversals, if I show you all the traversals, this was my first pass. This was my first pass. This was my second pass. Fast pointer is moving at 2x speed. Slow pointer is moving at x speed. Okay. So my fast pointer is here. My fast pointer position is here. Fast pointer position has become here. Then my fast pointer comes from here to here. Then here to here. Here to here. Okay. So there comes a point that my fast pointer is equal to slow. But suppose if my linked list is ending, suppose if my linked list is ending, okay, this is null. Suppose there is no loop. So my fast pointer is here and my slow pointer is here. For first iteration, remember, listen to me carefully. For first iteration, my fast pointer has come here, my fast pointer has come here, and my slow pointer has come here. My slow pointer has come here. Makes sense? Makes sense. Okay. For the next iteration, my fast pointer would be going somewhere here, whereas my slow pointer would be coming somewhere here. Okay, makes sense. Makes sense. Okay. My slow fast pointer, my fast pointer will be somewhere here, and my slow pointer will be somewhere here. Sure, sure, sure. Okay. So, so So as I can see, if I'm moving in a straight path, if I'm moving in a straight path, my friend and I am moving on the straight path, we can never meet. If he is moving at 2x speed than mine, if it is moving at 2x speed than mine, I can never chase him. I can never chase him. But if he is moving the same path again and again, I may meet him again. Okay, so this is the analogy that we are following. What would be the ending condition? Suppose there are two nodes, and this is my fast node, this is my slow node. If I consider the first iteration, so my first iteration only, my fast pointer becomes null. First pointers become null. Okay. So my ending condition should be, so after this iteration, my slow is here. So after this iteration, if I still try to move again, my fast pointer would also try to move again, but it is null, so it doesn't have any reference. It doesn't have any next value reference. Next value reference. So my ending condition should be while my fast exists and my fast of next exists. Okay. Why fast of next? Why fast of next? Because why fast of next? See, because if my fast pointer is at the last position, suppose if my fast pointer is at last position, okay, so there should be something I should jump upon. There should be something I should jump upon. If there's nothing that I can jump upon, there's nothing like my second pointer. Okay, there's nothing like my second pointer. Why I should care? Why I should care? Okay, so this would be my ending condition. This would be my ending condition. If I try to write the code for the same thing, okay, so my slow pointer is moving at x speed, my fast pointer is moving at 2x speed. There would be a point, they will both meet, and if they meet, if the slow pointer becomes equal to the fast pointer, then I'll return true, else I'll return false. I'll just declare both the pointers and declare this position as fast, as head. Okay. While my fast exists, and my fast of next exists. Okay, so my slow would be moving one position and my fast would be moving two positions. If my slow equal to fast, return true, and if the loop ends, just return false. Okay. And why I'm not writing this statement at the first line? Why I'm not writing this here and I'm moving it to the last line? Why? Suppose if I'm moving, if at the first position my slow pointer is equal to my fast pointer. Slow pointer is moving is equal to my fast pointer. Okay. So at this case, if I move it to the first line, if I move it to the first line, it would be true for every other case. It would be true for every other case because it would detect the condition that my slow is equal to my fast for the first node only, and it would simply return my first node. It will return true for all the cases. So I am moving both the pointers first, and then I am traversing it one by one. Okay, I'll just try to submit it directly. Okay, so as we can see that this has been submitted. What I am doing here, if I try to summarize, I am using the slow and fast pointed approach. By the analogy, by the analogy that if there exists, if a person is moving to x speed than me in a circle, in a then he or she would definitely cross me again. Definitely cross me again. So if that happens, if we become equal, I just wanted to return true. I want this to return false. Okay, this was about the logic. Now if I come to the time complexity, as I'm moving my slow pointer and my fast pointer, it becomes somewhere equal to O of n only. Somewhere equal to O of n only. Okay, so time complexity becomes O of n. No extra space I am using, so O of n. This was about the Leetcode solution of the problem linked list cycle. I hope you guys enjoyed it. If you have any doubts regarding this question, you can just post your comment right below this video and Do not forget to like, share, and subscribe. Okay. Have a good day. Bye bye.